Hello all and welcome to this presentation about a WebGIS portal about regarding Kenya's groundwater management or system. This is a portal which has been developed using open source technology. I mainly used HTML, CSS, JavaScript, as well as jQuery for the front end, and I've handled the backend logic using PHP as well as PostgreSQL and PostGIS for the database. So this data is hosted in the cloud in a PostgreSQL instance in the cloud, and it contains about more than 21,000 groundwater points. This is data that I obtained from UNESCO. They have a platform called IPS Wins, which you can get various types of data. But now I downloaded it and in GeoJSON format so that I can build a platform around it. We're using open source tools. So as you can see, I have what you call two sets of data. The GeoJSON, which I have clustered in this nice marker clusters, as well as county data for Kenya. So, see as I hover around it, you can see data of Kenya's counties as well as the county code, such that when I zoom here, you can see like this is Garissa with a county code of 007, and I rather give a SQL logic to ensure that all the data has the code, the ID rather has a code contains a code for the country as well as the county. See, so this is a portal with full CRUD operations. CRUD meaning create, read, update, and delete. And I'm going to show you, for instance, the read where you can query. So I'm going to search for a well in Nairobi 254047. So let's go for the first one. Find well. So you can see it has zoomed to this point, okay, which is an unprotected dug well in Kilimani. Okay, so let's change the base map so we can see properly. So looks like it's unprotected dug well in Kilimani. So how about we create a new let's create a new borehole maybe in this compound, right? So I can insert a new well. I call it a borehole. Name of well I can call it what any name. Haja, maybe Haja, Hajaka, something like that. I don't know. County, this is Nairobi County. Locality, of course, this is Kilimani. Elevation, I'll give it maybe a 1620 elevation. Yields, let's say 45. Depth of maybe 250. Geometry now means I need to come here and maybe put it here. Okay. So I usually want to add this new one, of course, and then I insert wow. Okay. And then ideally it's supposed to upload itself here. Let me cancel this and grab this. So you'll see something updating here. a color-coded well. Could be a borehole, could be a dug well, but it should appear here. Yes, you see, it has updated. And it has been given a well ID of 011. So I have created the SQL to kind of automatically issue a well ID. So so let's search it. 254 011 047 rather 11 find well. Okay, so this is the one we've just added. We can also delete it. We can update it. Let me show you how we can update it. Sorry, no what. Let's refresh a bit. Loading a bit slowly. Just give it time because it's getting the information from the cloud. So meanwhile, as it is loading, you can see I also have information about the metrics, but we'll come back to that. But so we were searching an ID of 254 047 011. Okay, so let's find the well. It should zoom to the well. Okay, and let's give it the Israel imagery. You can see you can also update it. Okay, I can maybe change this to 50. I can change this to I don't know, to maybe depending on where if you have increased the depth of the borehole, can update it, and it still updates. So there's a sweet alert here to show you that you're making changes. So this should be 300. Let's give it time to update. See, it's now 300. So what is the other thing? Metrics, right? So I did chart.js using chart.js. I created these charts that shows you the the number of boreholes per county. So this is Baringo has 225 boreholes. This is Makueni has protected dug wells of 150. This one is Taita Taveta has at 121 protected springs. So as you can see, I use a log scale because there was a disproportionate amount of groundwater wells in especially Kakamega and Vihiga. So having just a normal scale would make these other sets of data unreadable. So this is a stacked bar. Okay, it contains information about all the types of wells in one bar. Yeah. So there's also another one to show you the well type distribution. So here you have the number of protected springs, the number of boreholes, the number of unprotected springs, unprotected dug well. See? So, and these charts are dynamic, which means that if you want to, if you update them on the portal, it's able to update on the metrics as well. Okay, so very important. So maybe another thing we can do, we can delete. I think we have not deleted, so we can choose this one and then delete it. And it will disappear from the database. Delete. Okay, so we should see it just disappear. And remember, it was it had an ID of 011 at the end, so we shall query it and see that it is actually disappeared. See, it has disappeared. So let's try and query it. 011 again. Find well. See, well not found. Okay. So we have deleted it. So this is the end of this small presentation to show you these 21,000 what do you call them, groundwater wells that I have created in this WebGIS portal. If you have any questions, you can show or maybe ask in the comments, and I'll be happy to address them. Thank you very much for your time. Thank you. Thank you. Have a good day.